So in this video we continue talking about Gaussian elimination. So the first problem that we do in this video says row reduce the following matrix. And as we can see here, the matrix doesn't say that this corresponds to particular system of linear equations. We don't know if the last call, but we don't know if this is a coefficient matrix or augmented matrix, but that doesn't matter because, as we're going to see very soon, we can interpret a particular matrix in a different way. It doesn't have to be interpreted as a system of linear equations. Okay, so the first thing that we want to do is figure out what is going to be our pivot position first of all. Okay, so we look at the top leftmost entry is this one right here, right? So this entry here, can this entry be made into 1? Well, we can do that first of all just by flipping the first and the second row, right? We can just interchange the first two rows, so row 1 and row 2 will just change their places, right? So now row 2 becomes a row 1 and row 1 becomes a row 2. So we are going to do this very slowly. Later on you can do this slightly faster, skip some steps as long as you write everything, whatever you're doing, as long as you write it here. Okay, so the second row becomes the first row, so 2, 4, -10, 6, 12, 28, and the first row became our new second row, so 0, 0, -2, 0, 7, 12, 2, 4, -5, 6, -5, -1. Okay, the thing that you always want to check is, somebody might say, okay, why did we replace the second row with the first one and not the third row with the first row? You could have done that, and that wouldn't have affected the final outcome if everything went well. But what do I notice? I notice that the second row, right, is divisible by 2. Every entry in the second row is divisible by 2 without producing any fraction. So every number here is even number. And why do I say divisible by 2? Because in order for the first entry to become 1, I just have to divide the whole row by 2. And if I divide this row by 2, then I would avoid any fractions. Not that anything is wrong with fractions, it's just that some students prefer not to use them, okay? So that's not always a good reason, but why not? So here I just say my new row 1, right? So this is from now on, this is our row 1 divided by 2 to become our new row 1. And now, as you can see, we are obtaining that leading 1 that we needed. So the first row divided by 2, we get 2 divided by 2 is 1, 2, -5, 3, 6, and then 14. And here I have 0, 0, -2, 0, 7, 12, 2, 4, -5, 6, -5, -1. Once we have obtained the leading 1, now I need to eliminate all the entries below that leading 1. Every entry below the leading 1 should become a 0. So the first one is already 0. Now how am I gonna make this 2 in the third row a 0? So I want to change the third row, so I start with that one. So I say row 3, and what is going to be my action? I'm thinking, what do I have to do with this entry in order to become, using the first entry, using the first row, in order for it to become a 0, and then apply that action to every single entry in the row here? Well, that's row 3, which is 2, minus 2 times row 1, so 2, minus 2 is going to be 0, and this becomes new row 3, okay? So I'm not affecting at this step, I'm not affecting the first two rows, so I'm just copying them. 1, 2, negative 5, 3, 6, 14, 0, 0, negative 2, 0, 7, 12. Okay, so 2 minus 2 times 1, 2 minus 2, 0. 4 minus 2 times 2, that's 4 minus 4, 0. Negative 5 minus 2 times negative 5, this is negative 5 plus 10, gives me 5. 6 minus 2 times 3, that's 0. Negative 5 minus 2 times 6, that is negative 5 minus 12, negative 17. And the last one, negative 1 minus 2 times 14, that's negative 1 minus 28, that's negative 29, right? I hope I didn't make any small mistake with the calculation. Negative 29. Okay, so now below the leading one, I have zeros, right? We move on. What do? We cover the first row in which we have obtained leading one, okay, and check what is going to be our next pivot position. Well, here, can I make this a pivot position? Well, no, because there is no way that here I can get one. I can, even if I flip these two rows, it's going to become 0, and from 0 I cannot get to any other constant without the help of the row below that, right? So I move on, and I see that this is our pivot position right here. So the question is, what I'm going to do with this one in order to make it 1? Well, that's very simple. I will just divide the whole row. Right, by negative 1 over 2. Sorry, by negative 2. I will divide it by negative 2, which means I will multiply it by negative 1/2. Row 2 becomes new row 2. Okay? So I'm not doing any changes for the first two rows. 1, 2, negative 5, 3, 6, 14, 0, 0, negative 2 divided by negative 2 is 1, 0 divided by negative 2 is 0, 7 divided by negative 2 is negative 7 over 2, 12 divided by negative 2 is negative 6. And then you copy the 0, 0, 5, you copy the third row, 0, negative 17, negative 29. Okay, now let us see. This is the leading one right here, and then I have to eliminate the entry, all the entries below that leading one. I have to make them 0. So I have 5 here in the third row, so I say row 3, sorry about that, so row 3 minus 5 times row 2 becomes my new row 3. Okay. So what do I get? The first two rows, we just copy the first two rows. So 1, 2, negative 5, 3, 6, 14, 0, 0, 1, 0, negative 7 over 2, negative 6, and then 0, 0. 5 minus 5 times 1 is 5, so 5 minus 5 is 0. 0 minus 5 times 0 is 0, so 0 minus 0 is 0. Right? So what do we have here? Negative 17 minus 5 times negative 7 over 2. That's equal to negative 17 plus 35 over 2. or that's negative 34 plus 35 over 2. So that entry becomes just 1/2. And the last entry is negative 29 minus 5 times negative 6. That's negative 29, plus 30, and 30 minus 29 is 1. Okay, so now we continue. You cover the first and the second row because the first row is done, second row is done, right? Now in the third row, what is going to be our pivot position? This one right here. So what do we have to do in order to make that one a leading one? Well, just multiply the whole row by 2. So 2 times row 3 is my new row 3. Copy the first two rows, 1, 2, negative 5, 3, 6, 14, 0, 0, 1, 0, negative 7 over 2, negative 6, 0, 0, 0, 0, this one 0, so 1/2 times 2 is 1, 2 times 1 is 2. Okay, so this is a reduced form of the matrix. This is the echelon form of the matrix, but we said write down the reduced version of this matrix, which means that we have to eliminate not only the entries below the leading ones, but also the entries above the leading ones. So these are the leading ones, right? There is no entry above this one, so we're done with this one, leading one. Using this leading one, I have to eliminate this entry here, and using this leading one, I have to eliminate these two entries, right? We always start with the last leading one when we do this backward phase. Okay, so here you can say now I'm going to affect, right? I want to change the second row. I want to make this entry 0, which is negative 7. I have to improve my 7. I want to eliminate negative 7 over 2. I want to make that one a 0. So I say row 2 plus 7 plus 7 over 2. Row 3 is my new row 2. So 1, 2, negative 5, 3, 6, 14. No changes in row 1. No changes in row 3. And then let's say 0 plus anything times 0 is 0. 0 plus 7 over 2 times 0 is 0, so 0. 1 plus 7 over 2 times 0 is 0, so 1 plus 0 is 1. And as you can see, using this method, I'm not changing the leading one. That stays as it is. 0 plus 7 over 2 times 0 is 0, so 0. And here I have negative 7 over 2 from row 2 plus 7 over 2 times 1, well, that's 0. And this one here, negative 6 plus 7 over 2 times 2, these two cancel, negative 6 plus 7 is 1. Now I need to eliminate this entry because it's above this leading one. So I'm going to change the first row, and I start with that one, row 1 minus 6 times row 2. It's my new row 1. So I'm changing the first row. 1 minus 6 times 0. 6 times 0 is 0, so 1 minus 0 is 1. 2 minus 0 is 2. Negative 5 minus 0 is negative 5. 3 minus 0 is 3. 6. And now for the first time I have 6 minus 6 times 1. 6 minus 6 is 0. And 14 minus 6 times 2, well, that's equal to 2. And then copy the last two rows, 0, 0, 1, 0, 0, 1, and 0, 0, 0, 0, 1, 2. Finally, the only thing that we have to do is eliminate this entry, make it a 0. How are we going to do that? Well, that's row 1 plus 5 times row 2, right? I'm going to use the leading one to eliminate that one. Becomes my new row, row 1. So, and with that we're done. So you have 1, 2, negative 5 plus 5 times 1, negative 5 plus 5, that's 0. 3 plus 0 is 3, 0 plus 0 is 0, and here I have another change. 2 plus 5 times 1, that's equal to 5 plus 2, which is 7. And then just copy the other two rows. And now you can go and check the conditions, by which we determine whether a particular matrix is in a reduced form, and you will see that it satisfies all the criteria for this matrix to be called a reduced row echelon form. Okay. If you're asked to solve a system of linear equations, okay, using the same method, well, we have done an example like this in the previous video. The only difference is that these equations here represent planes represent four-dimensional hyperplanes. Okay, so geometrically you can try to interpret them somehow in your head, but it's impossible for me to show you what these hyperplanes look like, right? So what do we do? First, we create the augmented matrix. So take the coefficients here. So that's 1, 3, 0, negative 4, 5. Right? Be careful. We have four variables. So that's x1, x2, x3, and x4. You see x3 here is missing. That means it's multiplied by 0. The second one, negative 2, negative 6, 1, 10, negative 10, and then 6, 18, negative 2, negative 28, 30. Okay. Find the pivot position. This one right here already has leading one, so right away we start into eliminating the entries beneath it, right? So first I want to eliminate this negative 2, so I operate on the second row, so I start with that one. Row 2 plus 2 times row 1 becomes my new row 2. So I just change the second row, so I copy the first row, 1, 3, 0, negative 4, 5, negative 2 plus 2 is 0, negative 6 plus 3 times, plus 2 times 3, that's also 0, okay, 1 plus 2 times 0 is 1, 10 plus 2 times negative 4, it's 2, and negative 10 plus 2 times 5 is 0. And then copy the third row, 6, 18, negative 2, negative 28, 30. Okay, now I want to eliminate this entry right here using the leading one. So I will operate on the third row. I will change the third row, so that's what I start with. Row 3 minus 6 times row 1 becomes my new row 3. Okay, so copy the first two rows, 1, 3, 0, negative 4, 5, 0, 0, 1, 2, 0, and then I have 6, minus 6 times 1, well, that's 0. 18 minus 6 times 3, that's also 0. Negative 2 minus 6 times 0 is negative 2. Negative 28 minus 6 times negative 4, this is 24, so 24 minus 28 is negative 4. And then 30 minus 6 times 5, that's 0. Okay? I'm done with the first row because I have obtained the leading one and I have eliminated the entries below that one. I've made them 0. So cover the first row and find the pivot position. The pivot position is right here and it is already a leading one. Okay? So right away I'm going to jump into eliminating the entries below that leading one. So that means that I want to eliminate this negative 2 in the third row. So I start with the third row, row 3 plus 2 times row 2, it's new row 3. Okay, so I copy the first two rows, 1, 3, 0, negative 4, 5, 0, 1, 0, sorry, 1, 2, 0, and then you have a 0, 0, negative 2 plus 2 is 0, negative 4, so negative 4 plus 2 times 2, it's also 0, and then 0 minus 0 is 0. Okay, and at this point we can stop. Why? Because I have two leading ones. The entries beneath those leading ones are 0, and the entry above this leading one is also 0. So this system is in reduced row echelon form already. Now the only thing that we have to do here is write the solution of this system. First of all, how many solutions these systems will have? As we said in class, if the system includes this row of zeros, okay, so all the coefficients are zeros, and in the augmented matrix the corresponding entry is also 0, then we're talking about infinitely many solutions, right? The second thing that I said in class, I gave you this amateur definition of a rank of a matrix. What is the rank of a matrix? Following this amateur definition is the a number of non-zero rows. So rank, what is the number of non-zero rows in this matrix? That's 2. What is the number of variables? Well, the number of variables is 4, right? I have 4 variables from x1 all the way to x4. Okay? This implies that we will have 2 free variables. Okay? The number of free variables is equal to the difference between the number of variables and the rank. Okay, so if we have 2 free variables and the number of variables is 4, we have how many? We have 2 and 2 basic variables. Okay, now let's read out the solution. Let's read out the solution of this system. x4 doesn't have a leading 1. So you say that x4 is equal to t, some dummy variable, okay? x4 is equal to t. That's our first free variable. Okay. Now look at the second row. Write the second row as an equation. 0 times x1 is 0, plus 0 times x2 is also 0, plus 1 times x3 plus 2 times x4 is equal to 0. Okay, these are just zeros, right? So forget about them. So you have x3 plus 2 times x4, that's equal to 0. But x4 is a free variable, we call it t, right? So x3 is equal to negative 2x4, or in other words, x3 is equal to negative 2t. Now we move on. What about x2? x2 doesn't have a leading 1. So we have that x2 is also a free variable, right? Give it some name. Let's call it s. And finally, how much is x1? 1 times x1 is x1, plus 3 times x2, plus 0 times x3, minus 4 times x4 is equal to 5, right? From the first row. So translate the first row as an equation. This is what you have. But x2 is s and x4 is t, so bring those two terms on the other side of the equation and you get the expression for x1. That's 5 minus, bringing this on this side, right? Minus 3s plus 4t, because x4 is t. Okay. And finally, how do we write the solution? Well, you can write it as a column: x1, x2, x3, x4, right? And then you will see next class why we adopt this notation. Okay, it's equal to, how much is x1? 5 minus 3s plus 4t. How much is x2? x2 is just s. How much is s3? x3, that's negative 2t. And then x4 is just t. Now, how do we write this solution? You separate them. You see there is a constant here. There are some terms multiplied by s and some terms multiplied by t. So you split them in the following way: the constant by itself, so 5 in the first row. In the second row there is no constant by itself, so 0. Here 0, 0, plus, now the terms multiplied by s, negative 3s, s in the second row, 0, because there is no expression in terms of s, 0, plus the terms including t, so 4t, 0, because in the second row there is no t, negative 2t, and then t. Finally, how do you write the final answer? You just factor out the free variables from these two columns. So that's 5, 0, 0, 0, plus s times negative 3, 1, 0, 0, plus t, 4, 0, negative 2, 1. And this is the solution of the given system of linear equations in 4 variables.